Hello friends and welcome back to another lecture. In this lecture I am going to discuss about exceptions and errors in Java. So let us start. First of all, what is an exception? So exceptions are certain event which disrupts the normal flow of the program. So a program is running from a particular line to another line. In between an exception will occur and it will halt the program and it will exit from the particular line and cause the program to end terminate badly. So that's how the exception will work. So it will terminate the program and causes it will throw a particular error to the particular console and it will show the message in the console that particular exception has occurred. And like that, exceptions are there. Now let us discuss about errors. Errors are some abnormal conditions which will occur usually due to lack of resources, out of memory error, and stack overflow error. These kind of errors will occur due to resource problems. So errors are usually not due to our code, usually due to lack of resources, but exceptions are usually due to our coding problems and other handling problems. Everything will be due to these exceptions. Next, there are different types of exceptions. There are two major types. One is checked and other is unchecked. So checked exceptions means those will be checked. We have to check the compile time. We have to check those exceptions. And the example for this kind of exceptions are SQL exception, IO exception, etc. So there are many different kinds of checked exceptions. Please go through all the exceptions. And next is the unchecked exceptions. So unchecked exceptions, we have to don't need to handle it. The we have to catch them separately. For example, null pointer exception, arithmetic exception. If you handle all didn't handle also it will run, but for the specific condition it will cause errors in the runtime. So that is a different types of exception. Now let us discuss about exception hierarchy. So exceptions follow a hierarchy in which throwable is the superclass of all the classes as seen in the picture. You can see in the diagram. So throwable is the superclass of all our exceptions. And here you can see it will extend to two classes. First one is error and other is exception. So error down the line it will stack overflow error, out of memory error. These all errors will extend the particular class, errors class. And from the exception side you can see the IO exception and other exceptions are there. And after that you can see the runtime exception class, which will be another subclass of and another subclass. And in the runtime exception class will be implemented by the arithmetic exception and other exception classes. So you can see here in this picture. So that's it about exception hierarchy and the theoretical aspects of exceptions and errors. Now let us see some programs in which I will see some exceptions occurring. Now let us see a program in which there are some exceptions. So in this programs we will see some exceptions occurring in our program. So here you can see the variable is initialized to null, and after that I am trying to print the caret method. So this will throw an exception. You can see I'll run this program. I'll try to run this program. At that time it will throw null pointer exception. You can see the message also here. So this is how one type of error is null pointer error, which is most commonly seen error. To avoid this error, what we have to do is we have to provide an if loop, if condition, and inside that we have to check the null, whether the particular string is null or not. There is another way of doing this using optional classes, which we'll discuss in later in this section. So let us see another program on exceptions. Now let us discuss about another error exception in Java, which is arithmetic exception. So here you can see in this program, I am trying to divide a number by 0. So it will throw an arithmetic exception. Let us see this exception. Here you can see, so particular line of the particular main method main thread, it will throw the exception message will be like this, and it will show that arithmetic exception is thrown at that particular line. So this is another type of exception, which is arithmetic assertion, which is a uh, unchecked exception. So we have to handle it by how we will handle unchecked exception. This kind of exceptions is we have to write an if statement or something. You have to validate the denominator so that this exception will not throw. So that's it for this program. Let us see another program in which another exception is occurring. Now in this program we are going to see another error exception called as array index out of bound exception. So this exception occurs if we see if you declare an array and that array we are trying to access an element of position which is not present in the array. That time this error will be thrown. Let us see the how the exception is getting thrown. So here you can see the exception message has been coming. So it is showing that array index of exception index out of bounds exception is thrown. So that's how this exception is there. So this exception can be eliminated by checking the index should be less than the length of the particular array. Like that we have to handle a additional condition and handle it. So that's how we can handle this exception. And in this lecture we are seeing about exceptions and errors, and also seeing how exceptions are caused by the disrupts the normal flow of the program, whereas errors are abnormal conditions. And also we are seeing some programs in which arithmetic assertion, array index of bounds exception, all the exceptions are being thrown. So thank you for watching this lecture. I'll come back with another lecture. Hello and welcome back. In this lecture, we are going to discuss about try catch and finally, so the how to handle exceptions in Java. We will understand after this class. So let us start. So the first thing are the different ways of exception handling in Java. So there are three different ways to handle exceptions in Java. The first one is using the try catch and finally block, and the second one is using the throw keyword, and another one is using the throws keyword. So these keywords we will see in the next lecture, and now in this lecture we are focusing on try catch and finally, which is the basic method to handle the exceptions. So let us start. So let us discuss about try catch block first. So try we can handle exceptions by declaring a try block. Inside that we will have the statements which is throwing the exception, and followed by the try block. We have to specify a catch block or a finally block to handle the particular exception. So in the catch block, we will declare our exception class, and then we will write the message or print the particular exception message into the console, or we will handle the exception like that. So that's how exceptions are getting handled. So you can see the try block, more information about try block. So you can see here. So the catch block is used to handle the errors, and we have to define specifically. We have to write which kind of exception is getting thrown in the program in the catch block, and you will see the syntax of them when we write the program. So let us see more information. Here is another more information about try catch and finally block. Here you can see. And one more thing about this is we can handle multiple exceptions in the catch blocks. So there will be multiple catch block for a particular try that is allowed, and we can handle multiple exceptions in single catch block by using the pipe symbol. So if you use the pipe symbol, why it was lately introduced into Java, which we discussed in the Java version discussion class. So this is a pipe symbol which is added so that multiple exceptions can be handled at a single line. So we just need one exception object for all the type of exceptions in a single line. Next we will discuss about finally block. So finally block is a block which is used to execute the necessary code of our program. For example, such functionalities such as closing a file and flushing the file, or some so you want to do something. If even if the program terminates, you want to do some task. So that those important tasks are written in the finally block. such as closing and that's those kind of tasks. So this is about the finally block. And one more thing about finally block is that it always executes even if the program throws an exception. The code of the finally block will always execute. So that's about this theoretical aspects of exception and the finally block and catch block and finally block and try block all these blocks. Let us see some programs based on these. Now let us see a program based on exception handling in Java using try catch block. So here you can see I have an arithmetic assertion which is occurring in this program. Before that you can see the syntax of try. We have to declare a try block like this, and inside that we'll have the catch block. Here is a catch block, and this is how we will write the try catch statement in Java. You can see the whatever the exception at occurring statements, the statements you can have to cover it up with the try block, and then in the catch block you will define the particular exception which is getting thrown, and we have to handle the exception by either printing the particular message into the console. And here you can see system.error.println method is there. This is a method to print the error messages, and it will show in red color in the screen when we see the output. Let us see the output of this program. So here you can see the output of this program. One by one, these exception messages are getting printed. First line is the red color, whatever we are using system.error.println method we are using to print, that is getting printed, and after that the print stack trace method is getting called. So it will print the particular stack trace, whatever the errors are thrown in the particular try block, that will get printed here. So that's how we will handle exceptions using a try catch block. Now let us see another program. Now let us see a program in which we are using try and finally together. So you don't need to always have a catch block when you are using try. You can have a finally block. So the finally block is used to execute a statement. Even if the error throws, it will execute. So here in the finally block, I am just printing a message. Finally block called, finally called, like that message I am printing. And let us see the output of this program to understand how the try finally block is working. So here you can see the output. This finally is getting called even if the exception is thrown. Here you can see the exception is thrown, but still the finally block will always execute. That is about finally block. So the finally block will always execute even if the error throws. And if you are terminating with using system.exit or some methods, at that time only the finally block will not execute. Well, let us see another program based on try catch and finally. Now let us see a program in which all the try, catch and finally block, all three blocks are using. So here in this program, I am creating a null pointer error as well as an interrupted exception. Both exceptions will be thrown in this kind of program. So I'm simply I'm trying to use the contains method which is accessing to a null reference. So it will throw a null pointer error exception. And another thing to understand here is the thread dot sleep method, which will throw a checked exception, here you can see interrupted exception it will throw. So both exceptions I am catching using a pipe symbol. So I discussed in the theoretical class that we can use the pipe symbol to catch multiple exceptions in the same line. And one more thing to remember is if there are, for example, there is a relationship in between these classes in exception classes. There are some exception classes are the subclasses of the particular exception classes. So in that scenario, the specific class should be placed in multi catch block conditions. The specific class should be placed above the generic class. So for example, exception is the most generic class, so that should be placed last, and other classes should be placed above the particular exception class. So if you don't do that, the compiler will throw you an error stating that the specific exception should be placed first, then the generic exception. So that's how about placing the exceptions in the particular catch block. And the next finally block is there. In the finally block, before finally block, I want to tell you about a method get message. So here I am printing the get message. So get message will exactly tell what is the particular error is due to. That will return you the error message, what is the error message is due to. It will not have any other line number, all the things will be removed, only the particular error message will be printed. So we will see how the output will come. And in the finally block we have put some comment so that to know that finally block will always execute. Usually finally block is used to close the buffers or close the files, and so that even if the program terminates abruptly, it should not affect our code. Now let us see the output of this program. So here you can see this finally block is getting executed, and this particular error message is getting thrown. So the get message will give you the particular error message why that error occurred, and that's it about this program. So in this lecture, we are seeing about different types of catch block and try block and finally block. These blocks are used to handle exceptions. So if exceptions comes, we have to handle manually by giving these particular blocks and handle the exceptions. So using these blocks, we will be able to handle multiple exceptions at the same program, and we have seen the scenarios where multiple exceptions are occurring and we are handling those exceptions. So thank you for watching this lecture. Please continue watching the series, and then I will be back with the next lecture. Hello friends, and welcome back to another lecture. In this lecture we are going to discuss about custom exceptions in Java, exception classes in Java. So we will create a custom exception classes based on the logic. So the first thing to understand is these all classes will be derived classes of the exception class. We seen the exception hierarchy in the last lecture where throwable and exception and error classes we seen. So how the relationship is there. So we will create a particular, for example, we will create a checked exception by extending the exception class, and then we will create a unchecked exception by extending the runtime exception class. So these two classes we have to extend in order to create our custom exceptions. And one more thing to say is there will be a super constructor which will invoke in the particular exception, our custom exception classes, so that we will be able to pass the error message as a constructor. So like that the message will be passed to the main class. So like that it is. So when we create a custom exception class, our class name should have exception in the at the last. So it will be my checked exception or my unchecked exception. Like that we can create our class names. So that's it for the theoretical aspects of creating a unchecked exception or checked exception in Java. Let us see some programs based on creating these kind of exceptions. Now in this program, let us see about the checked exception, how we can create a custom checked exception. So here you can see in this is a particular exception class, my checked exception class. So in this class, I am extending the exception class, and following that, I am giving a serial version UID in the field, declared a serial version UID field in the particular class because this class is need to be serialized. So we will talk about serialization when the serialization lecture will come. For now, let us leave that thing. It is done so that any warnings should not come in our program. So next we will discuss is the constructor of this particular method, particular class. So in the particular class, I am calling the super dot and passing the particular message from the constructor to the super class. So super class is the exception class where this constructor will handle the particular message. Now let us see the main method of this program. So here is the main method, main example one program. So in this main method, I am just using the throw keyword here. You can see to throw the particular exception. So whenever you want to throw an exception, you can use the throw keyword. You can use the throw keyword inside the catch block also, so that you can chain and call the multiple exceptions. Like that, you can throw exceptions. and here I am throwing exception. This is one way to throw the exception, and I am taking using the catch block to catch the particular exception and print the exception message. Let us see the output of this program. So here you can see the output. The values are coming one by one. You can see the exception message is coming. So particular exception message as and whatever we are providing in the constructor for the particular exception class is getting printed here. The message is getting printed. So that's it for the output of a custom exception class. Now let us see custom unchecked exception class. Now let us see a program based on unchecked exception, custom unchecked exception. So here you can see I have created a class, my unchecked exception. So in that class, I'm extending the runtime exception class. So like this, you can create the unchecked exception. And here I have a serial version UID to because this class is serialized. So that is how we have to provide the serial version UID, and this value will be provided. And after that, in the constructor, I am calling the super constructor with the supplied parameter message, so that I want to pass some particular message which I put in the constructor of the particular class to be passed to the its super class. So that's how it is. Now let us see the main method of this program. So here you can see the main method. In the main method, I have a method which will throw. You can see the throws keyword here, throws particular exception. So like this you can handle the exception either using the last example we seen using the throw keyword to throw the particular exception. Here you can throws to particular handle the method. In that method, whatever exception is there, you can throws that particular exception, and that way you can handle the exception. And next is I'm checking for a particular condition in the particular method, and if the particular value of the age is greater than 120, then I will print throw the particular exception, else I will not throw the exception. And in the main method I am calling this particular method with the two values. So let us see the output of this program. So you can see when the value is less than 120, there was no error. When the value was greater than 120, then the exception is getting thrown and the message is getting printed. Whatever message age is greater than, like that, it is printing. So the exception message is also printing. So that is about the unchecked exception, a custom exception in Java. So in this lecture, we are going through how to create custom exceptions in Java. In most programs, we need to create our own custom exceptions, and has to create multiple unchecked and checked exceptions. So at that time, we have to remember this thing that for unchecked exceptions, you have to extend the runtime exception class, and for checked exceptions you want to extend the exception class. So that's it for this lecture. Thank you for watching this lecture. I will come back with another lecture. Hello and welcome back. In this lecture we are going to discuss about a feature called as try with resources. So we have seen about the try block, how we can handle the exceptions using the try block. So in this lecture, we will discuss about a feature which was introduced into Java 7, which is called as try with resources. So in this feature, it will allow us to declare some resources, and the automatically the compiler will the close the resources for us. So we don't need to write dot close in manually. The compiler will automatically close those resources for us. Once the usage of the resources is done in the try block, then these resources will be closed automatically. The syntax for try with resources is try followed by a parenthesis in which we have to declare the resources which we want to auto close. And one more thing to notice about the try with resources is all the resources which we want to close should implement an interface called as auto closable, and then only the resources will be closed automatically. So that is it about the theoretical aspects of try with resources. Now let us see some programs based on try with resources. Now let us see a program based on try with resources. So in this program we are going to print a particular message into a file and then output a file, and we will see in the file how the message is being printed. So that is the goal of this program. Now let us discuss about try with resources. Now you can see this is the syntax for declaring the try with resources. Try followed by a parenthesis in which we have to declare our auto closable resource. Here the auto closable resource is the print writer object. So the print writer object equal to new print writer object. In the constructor I am passing the particular file object. So file object is part of the file API, which we will discuss in the further lectures. And file API will allow us to handle files. So here I am declaring a file followed by its path. So it will take path as its input string as its parameter, and here it is path. So yeah, we have to create a particular folder out in our project in order to this file to be created. And then next part is writer.println. So this will be printing the particular message into the file. So then we will be able to see the particular output, and then I am printing out a message into the console stating that the file is written. And finally in the catch block we can handle the particular exception file not found exception. So here you can see we can use try with resources like normal try only. Only difference is in parenthesis we will declare the auto closable resource, and we don't need to write dot close anymore. This auto close will, this try with resource will automatically close those resources for us. And now let us see the output of this program. So here you can see the output file is written, that is a message. Now let us see the file where it is written. So here is a file in the out path. This is a particular file which has been written. So that's it for the output of this program. Now let us see another program based on try with resources. Now let us see a program based on try with resources in which I only have a try block. There will be no catch block for this particular try block. Now let us see the program. So here is a program. In the class I declared a main method also I declared. In the main method I have printed out a message to input the particular number, and here you can see the try with resources. And in the try with resources I am using the scanner class. In the scanner class I will the constructor I will pass the system dot in, like that I will pass. And after that in the body of the try block I will have the scanner dot next int method to read the particular int value, and finally I will output the particular reader string reader int value into the console. So that's it about this program. You can see one more thing that there is no catch block. If you use normal try block, there should be compulsory catch or finally block. Either of one should be there. But for try with resources, it is not necessary to have a catch block. Let us see the output of this program. So here it is prompting me to enter a number. I'll enter a number, and then that's output as generated. So this is it about try with resources. So in this lecture we are seeing about the feature called as try with resources, which will close automatically the resources for us. So any resource which implements the auto closable interface can be used in try with resources, and it can automatically close the resources for you. So you don't need to like check for particular uh, resource and then we have to close it like that. We don't need to do now anymore. We can use the try with resources. It is used in any many places. For example, in database connection, all the places we can use try with resources where there are resources which implement the auto closable interface. Now that's it about this lecture. Thank you for watching this lecture. I will be back with another lecture in the next video. Thank you. Hello and welcome to another lecture. In this lecture, we are going to discuss about assertions in Java. So, what is assertion? So, assertion is a feature which ensures the correctness of an assumption which is made in the program. So, if in programs we will have some assumptions such as for example, if in a program of age calculation, we are expecting the age to be less than 120 of a person, so like that assumptions should be there. So these assumptions can be validated using the assertions in Java. And assert was introduced in JDK version 1.4. So this was feature was not available in the initial versions, and later it was introduced. And one more thing about assertions are there, that assertions can be by default they are expected to be true, but when the assertions are getting false, then the compiler will throw an assertion error. Usually we will not at all catch that as a error. The assertion error will print the particular message, what is assertion error, that we will able to understand. So assertion error will be thrown into the by the compiler if an assert statement is failing. And you can see the different syntax for asserts are assert followed by the statement, and that is the first syntax. And the second syntax is assert followed by the two statements, one statement, after that another colon and the statement. So we will see about assert, how the statements can different types of assert statements we can do, and in the programming part of this lecture. And let us discuss one more key feature about assertion is that assertions will not by default will not work in your program, in your environment. You have to enable a flag called as ea flag, or hyphen enable hyphen an EA or hyphen enable assertion. Those two flags has to be on so that the program should be executed. So if you are running your program in Eclipse IDE, you have to have the virtual machine arguments while running the particular program. You have to right click and go to the run as Java application, and we have to specify the virtual machine arguments as hyphen EA, like that we have to specify in order to assertions to work. So we will see the practical for this program now. Now in this program we are going to discuss about assertions in Java. So we seen about assertions in the theoretical aspects. So here now we will see a practical program. So in this program I am going to check whether number of goals scored is less than 10. So that is like an assertion condition for me. And here you can see the scanner object. I'm taking this, reading the scanner and reading the particular number of whatever the goals scored as input in this in the value, and I'm checking in the Boolean condition in the assert statement the particular Boolean condition whether it is less than 10. Assert statement will work. If it fails, if the goals code is greater than 10, then the assert statement will fail, and then there will be an assertion error. Let us see the output of this program. Before going to the output, we have to tell you one more thing, that you have to enable the as a flag ea hyphen ea flag in the virtual arguments for your particular program. So you have to, when you run as application Java application, at that time you can supply the virtual machine arguments. In that you have to supply the hyphen ea virtual machine argument, then only you will be able to see the assertion error. Now let us see the output of this program. So here you can see it is prompting me to enter some number of goals. So I'll enter a value. So here you can see I entered a large value and it is throwing an assertion error. So this is how assertions can be used in the program. So we can manually write some conditions to validate and assume that particular conditions to be true. And if it fails, then assertion errors will throw. So the people will know that there is a large value which is not assumed. So that's it about this output of this program. Now let us see another program based on assert keyword. Now in this program we are going to see the second syntax of assert keyword. So assertions can be done in another way. So here you can see in this program I am going to check height of people, so that if the height is less than a certain limit it will throw an assertion error, and if its height is greater than a particular limit, then I will throw an assertion error. So that is the goal. And now let us see this program. So here in this program, in the main method, I have declared a scanner object to hold the particular value which we will input, and then after that declaring the assertions. So one assertion is to calculate it is less than a particular limit, and another is to check whether it is greater than a particular limit. So this is how this assertion statement of the second type is there. Here you can see the message. If we can pass a string into the next statement, so that this message will be printed into the console when this assertion error will throw. Let us see the output of this program. So here you can see it is prompting me to ask enter a value. So I'll enter a large value. So here you can see it is throwing an assertion error stating the message too long. So the message what we printed in the along with the assert statement has been printed correctly. So this is how assert statement of the second type is there. So we can use assertions in programs where we are not sure about you want to assume something in the program to be always working fine, and if it is not working fine then there should be an error thrown. So like that we will write the code, and you have to enable the assertion flag always to work the assert keyword. So that's it about this lecture in assertions. Thank you for watching. I will be back with another lecture in the next video. Thank you. Hello and welcome back to another lecture. In this lecture we are going to discuss about optional classes in Java. So let us start this lecture. So in this optional classes, we will handle the null pointer exceptions in Java. So exception handling, it's important to handle the null pointer exception, which is the most common type of exception in which your object is referring to a null object, which means it is not referred to anything. So that will be the problem with null pointer exception. So it will, if you are calling any methods of a particular object and that object is null, then at that time there will be a null pointer exception. And optional classes are provided in along with Java 8, in which we can have a container to hold the both values, either null value or the value which will hold the particular value. Both can be holded in the optional container. So it is a class, basically it is a final class, so it will not, we cannot extend the class. And let us see some of the ways we can create the objects using optional class. So optional objects we can create using three methods. The first method is using the empty object. So optional dot empty, if you write, then you will get an empty optional object. And next method is optional dot off method. So the off method will give use can be used to initialize a particular optional container. And the final one is the optional not nullable, off nullable. So this, if you can, if the value can be null in this case, so we can initialize it with null or directly. So that case also it will work. And that is the three ways of having the optional objects in our program. Now let us see some of the methods which are present in the optional class. So the first method we'll discuss is get method. So if you have a value in a particular optional object, then using get method you will be able to get the particular value. So here you can see the return type is t, which means it's a generic method. So the generic method will return you the particular generic value, which will be like, it can be a string or anything, even object, anything it can be. It can be a any class, it can any type it can take, and it will return you the particular type when you use the get method. So the next method is present. Is present is a boolean method. It will return you a boolean value whether the value is present in the container or it is a null, it is not present in the container. So let us see the program in which we will be discussing more about these methods. And next is method is present. And if present will be evaluating a particular consumer. We will discuss about this when we go to the functional programming aspects. So let us, once you done with functional programming in Java, then you will be able to understand the next set of methods like map, filter, stream. All these methods are used to implement the functional programming aspects in Java. So once you done in this program, in this lecture, we are only focusing on the simple handling, how we can write programs based on how to handle null pointer exception and all. And but after learning this lesson, after learning the functional programming lesson also, you can work with optional classes with these kind of APIs, map, filter, and other APIs you can work. You will be able to understand the functionality. So let us start the practical example for this lecture. Now let us see a program based on optional classes in Java. So optional classes are used to handle null pointer exceptions. So let us see the program. So here I am trying to create an optional container of string objects. So let us start. So here I am first time using the optional dot is empty method to create the empty optional object, and I'm checking whether the particular value is present and these empty values are checking. So we will check whether these values are getting printed correctly or not. And after that I am initializing the optional class, optional creating the optional object using the off method, and I'm trying to get the particular value. Here in the above you can see I have commented out this line because if you try to get the particular element which is not present in an empty object, it will throw a no such element exception. It will throw the particular exception. And finally, if in the program I am using a nullable of nullable method to of the static method of the optional class to initialize a particular value. In there, I am passing the null value. So for optional of nullable also we can pass the nullable value and a null value, and after that I am using the or else method. So or else method, what it will do is if value is not present, then whatever you are supplied in the parameter will be returned back. So if there is any condition you want to execute and if the value is not present, then you can supply a particular value in the method and it will be returned back to you. So let us see the output of this program. So here you can see one by one the is present and the is empty is values are getting printed, and get value of the first, second one is printed, and finally or else method is working fine. It is printing me the particular value. Since there is in the value is null, it will return me the particular message whatever I'm printing. So that is about the optional class one program. Now let us discuss about another program in optional classes. Now let us see a program based on optional classes in which I will discover more methods based in optional classes. So let us start. So in this program we are going to discover about the two methods, if present and or else get method in optional class. So I declared an optional class here and a particular value provided of string, and after that I am declaring the if present. I'm using the if present method. If present method will take a parameter, if we take a value of a consumer class, so we have to create an object of the consumer anonymous in anonymous class consumer we have to create. And for that particular anonymous in the class there is a particular method called as accept method. As in the accept method to print use the particular handling of the particular length, whatever the length of the particular string is there, that I will be printing. So before that we are seeing how we handle null pointer exception. In before cases we will use to check whether s equal to null, then we have to check whether s dot length is there, like that we have to check previously. So if you use the if present method, then we can directly write this logic. So we will explain about the short, much more shorter way of doing it in the next example. Now let us see the next example. So here I am using the or else get method. Or else get or else get what it will do, it will do is but it will take the if the value is not present, if value is null in the optional container, at that time the or else get method will execute a particular function for you, so that you will be able to execute a particular function if the condition fails or the value is null. And let us see how the or else syntax is. Here you can see the or else syntax. So here you can see what this braces and this parenthesis followed by the particular value is called as a lambda expression in Java. So lambda expressions is used to use as a functional constructor. So in functional programming, it is used to mention about the particular implement the particular interfaces, abstract classes interfaces with abstract classes. So they are called functional interfaces. So lambda expressions are used to implement the functional interfaces. Here there is a functional interface, that's why I'm using the lambda. So the syntax for lambda is like this: braces for parenthesis followed by an arrow notation, and then you have to write the body of the lambda expression. So we will explain about lambda expressions in the lambda expression selection. For now, it is a way to or else get should work like this. If a value is not present, then this particular message should come. And let us see the output of this program. So here we before output I already mentioned, you can see the above anonymous in our class. So this notation can be simplified by using the simple lambda expression. So we can use the lambda expression in the above code also. So that's it for this program. Now let us see the output of this program. So here you can see the both the values are getting printed. That is the output of this program. And in this lecture, we are seeing about optional classes in Java. They can be used in many cases. They can be used in your our Pojo classes where we write them in the get method. So whenever getting is there we can return a optional object. And so that the person who handles the API will be able to understand that this value can be either null or not null, so they will be handling them correctly. So you can use the get method to return the particular value from the optional container, and you have to use other methods if present, or else get, or else or all other methods you can use. And there are further more methods there are there in the optional classes, such as map, filter, stream. All the methods are available in optional classes. You can discover then that once you learned about functional programming aspects, you will be able to understand these methods. For now, let us finish this lecture. Thank you for watching this lecture. I will be back with another lecture in the next section. Thank you.